again. There we go. Let's fix that. So again, welcome to the Argo Workflows and Events community meeting. Today, an overview of the agenda. We have two items on the agenda. The first one is going to be a lightning demo from Felix on a WebAssembly plugin, which is a really interesting project in which I think will be, I guess, available quite soon for people running Argo Workflows 3.3s and using template plugins. And the second demo is going to be some from Savin. Is that right, Savin? Pronunciation?
Yes.
On Netflix Metaflow, which is a new popular framework, I think is really interesting. If you've not already done so, please add yourself to the list of attendees in the document so we know where you're from, and don't be scared to speak up and say hi to everybody. For those who don't know what Workflows and Events is, just a very brief introduction. Argo Workflows is the most popular workflow execution platform on Kubernetes, and Events is often used alongside it to trigger workflows based on things like Kafka messages and so forth. My name's Alex. I am a principal engineer at Intuit, and I work predominantly on Argo Workflows as well as operational analytics, and previously on Argo CD. If you want to ask any question during today's demonstrations, feel free to find the right point in the demonstrations to ask it, or you can wait at the end, or you can also ask in the chat, and hopefully somebody will read out your question for you. That's absolutely fine. And if you want to find out more, obviously you can often come back and ask in the CNCF Argo Workflows and Argo Events Slack channel if you want to ask any more questions. Now, we are recording this, and the recording is usually available within about 24 to 48 hours if you want to share it, and we'll tweet that and share that in Slack as well if you want to know where you'll be able to find out about that. Okay, Felix, are you ready?
Yes, I'm ready.
Okay, Felix, take it away.
Yes, I will need to share my screen. So this was up. Yeah, okay. Now it should work. Give me a second. Nice. So you should see my screen, right? The presentation? You see it? Yes. Very good. Very good. Okay, thanks for having me. If you have questions, you can put them in the chat, as Alex said, or ask them at the end. So it will not be a very long presentation. So you will hopefully remember your questions until the end. I'm Felix. I'm a master's student at the Hasso-Plattner Institute in Potsdam, which is very close to Berlin in Germany. I'm currently writing my master thesis on WebAssembly and workflow systems. And this is why I decided to give the new executive plugins feature in Argo Workflows version 3.3 a try. That version is released today, so you can also try the plugin beginning today. And yeah, it is publicly available on GitHub, and I really invite you to give it a try if you want. But first, let me explain why WebAssembly. So you've come to know and love containers, which is what you're using today if you use Argo Workflows. And with containers, you put your application into a Docker image, and the Docker image contains basically a whole operating system and all its libraries and all dependencies. But as an application developer, what you really care about is only your business logic. And this is really the smallest part of the stack. So 90% of what you ship to the cloud and what you run with Argo Workflows is boilerplate. And your business logic is just a very tiny part of it. And this is why WebAssembly could be a good idea, is a good idea to be used also in the cloud. Because with WebAssembly, you don't need all the boilerplate anymore. You basically end up with small modules that encapsulate your business logic. And those modules can use what we call capabilities to talk to the outside world and access a database, for example, or do some HTTP requests. Okay, what do you get if you use WebAssembly? So first of all, it's about developer experience and ease of use. So you don't need to build or test Docker images anymore. You can just ship your application as a tiny module. And what's cool about this also is I think many of you could already be using MacBooks with an M1 or M2 processor, custom CPU architecture. And what's cool about WebAssembly is that all you build with WebAssembly is completely architecture independent, and it will run just anywhere. Another point is security. So Kubernetes security and container security is notoriously hard to get right if you use third-party images, or if you don't rebuild your images periodically every week, then you're basically in a lot of trouble. And WebAssembly is a lot less complex and more easy to reason about, which is why it's easier to secure. And the third point is performance. So, I mean, once a container is running, like the code executes approximately as fast as a WebAssembly module, but every time you start and stop a container, you have some overhead. This is what you also see in Kubernetes. It just takes some time until it begins running, and this management overhead is also not the case with WebAssembly, so it's just a lot faster. Okay, enough of the talking. Let me show you a quick demo. Hopefully you can see my VS Code here. What I did here is just a quick demonstration of how it looks to use plugins and WebAssembly with Argo Workflows 3.3. So what we're trying to do is print a QR code, which encodes the link to my repository and the current temperature in Berlin. And let me quickly start this workflow. And in the meantime, I can explain some stuff to you. So for fetching the weather, I'm using a really out-of-the-box Python container, which just talks to an API and produces an output parameter. So that's what you already know from Argo Workflows. And but the second and third step are actually more interesting, because they use the new plugin feature. And they say that they want to retrieve a WebAssembly module from this identifier. So in this case, they are hosted on GitHub's container registry. And this is basically all you need to run WebAssembly modules in Argo Workflows when you have installed the plugin. And now we can see, just like a normal workflow, the container or the pod has finished. The pod has given some information to the message step. And if we now look at the workflow, I'll find the name at the top. This one. Then we can see a beautiful weather with a Rust crab and a QR code to my repository. So that's what the WebAssembly modules aim to do. Cool. So this is how it looks in real life. And as a last step, just a call to action, you can really easily install plugins now. It's really cool to use. If you're interested, give it a try. And if you're interested in any of the topics that are listed here below, so WebAssembly in Kubernetes, or WebAssembly in every headless use case, or capabilities, or something like this, please don't hesitate to shoot me a message on Twitter or contact me on the CNCF Slack. And with this, I give it back to the rest, to Alex. Thank you.
Cool. Do you have any questions from the audience?
Yeah, I have a question on how the plugin development experience was for you. So any feedback you have on things that could be improved, or things you liked, didn't like?
So, I mean, initially I had some struggles with just understanding how to build the config map, but for this I already submitted like pull requests. And otherwise there was one minor thing about like the HTTP implementation, but otherwise I thought it was really straightforward to build plugins. So I would suppose that many people will start building plugins for useful use cases.
How do you get the modules into the app?
So the WebAssembly modules, I'm thinking about 2 or 3 ways. What I'm currently doing is that I use basically the same mechanism as Docker uses, so an OCI registry, Docker registry, because you can also, basically in a Docker registry, you can store arbitrary files, anything that you want. So you can also store WebAssembly modules. But there are like also other projects which could be useful. So there's a WebAssembly application package manager. And there's also a project called Bindle, which wants to really find a new way of bundling applications together. So there are a few ways. but the way that's implemented right now is the most interoperable because just use the same stuff as containers.
So it's like running a it's like image, isn't it? It's like pulling an image and running it, isn't it?
Yeah, it is. It is.
Interesting.
But,
I'm just thinking about
essence,
supply chain security on that aspect.
I mean, the whole supply chain security aspect is a lot easier with WebAssembly because it's not like there are no library dependencies or anything like this. So, for example, you could imagine that a WebAssembly module would not even depend on something like OpenSSL or any other library, because all the stuff that a module uses to talk to the outside world is provided by the runtime. And you would like update the runtime periodically, but that can be done way easier than updating each image. So that's what's cool
so
about
if I want to make a HTTP request in my module, how do I do that? You know, I have a WASM plugin that wants to make a HTTP request.
Yeah. So what I mean, there are a few options, but the thing that would follow the goal of WebAssembly most is that the WebAssembly runtime provides a method or a library to execute HTTP requests.
Okay, so you have to provide that.
You don't open a socket and like call anything, but the runtime provides means to talk to the outside world.
I won't ask any more questions.
On a related note, so what about file processing or access? So I see from your example, the WebAssembly module can accept like text input or parameters from the workflow, like a text that you pass to the whale, say. If is it possible for a WebAssembly module to, I don't know, pass in like a path to a file somehow and then do processing?
Sure. That is actually a feature that I still need to build, is to support like the artifacts feature of Argo workflows. And this could be represented as files, as reading and writing to files, yes. But like opposed to containers or opposed to normal programs, like with WebAssembly, it's all whitelisting. So by default, a module doesn't have access to any folder on your machine or any machine. So you all need to allow any operation that could potentially be dangerous.
I see. Okay. In terms of the actual execution of the WebAssembly module, where is that done? Is it offloaded to some deployment that is just running all the WebAssembly modules, or is a pod spun up to execute that? How does that part work?
So right now, because this is really the first iteration of what I'm trying to do, all the WebAssembly modules are run within the agent pod, which is created for every workflow. So every workflow gets their own agent pod. So this is the scope of the WebAssembly modules. But as a goal for my master thesis, I want to run the modules like in a distributed fashion. And for this, I can also link the project. It's called Crosslet. They basically, they play a node in the Kubernetes cluster and allow you to run WebAssembly modules as pods. So in the end, that's what I'm trying to do, because that allows you to use the full power of a cluster and not only the power of a single machine.
Yeah, that sounds really cool.
Thanks.
Cool. Okay, well, Felix, thank you very much. Of course, if you have any questions, do come and ask about it. I'm sure Felix would love if you want to try that out as well. Interested to see what other use cases we have. Okay, should we give Felix a bit of a round of applause? We haven't done this before.
Good job.
We should do more of this. Okay, cool. Thank you. So for our next demo today, we have Savin. He's going to be doing a demo on Netflix Metaflow. Savin, are you ready?
Yes. Let me just share my
Take it away.
All right. Can you guys see my screen?
Yes, we can.
Let me just move to a slideshow. Awesome. So I'm here to give you a demo about a project that I've been working for now close to like half a decade. And then I'll follow up with a short demo around the project. So as for my background, from 2016 till mid 2021, I was at Netflix, where my team was responsible for building Netflix's ML platform. And as part of that, we built a framework that we ended up open sourcing in 2019 called Metaflow. And that framework is pretty much sort of like responsible for running mostly all of ML at Netflix, all the way from sort of like, how does a data science prototype an ML model, and how do they sort of like, take that prototyped model onto production. And since 2019, there are like many organizations outside of Netflix as well that have adopted the framework. If you think about like in the streaming universe, we have Netflix, HBO, Amazon, in the bioinformatics space, companies like 23andMe, many financial services firms, many e-commerce firms as well. So many sort of like organizations who have many diverse needs around machine learning projects. These days, sort of like, they're in the market for an ML platform, and Metaflow sort of like then happens to be one of the choice that they end up making. Now, at Netflix, of course, if you look at sort of like the kind of audience that we were trying to cater to, these were data scientists who had a strong background in machine learning, advanced degrees in math, stats, physics, chemistry, any sort of like, quantitative discipline, but they weren't necessarily software engineers by training. And what that meant was there was sort of like usually a huge gap between prototyping something on their laptop, which was usually sort of like, quick and easy on a limited set of data with sort of like limited compute resources available on that, to sort of like scaling it out to the cloud and then eventually deploying that model into production. And also production pretty much sort of like also varied from project to project. So there were sort of like certain projects like Netflix recommendation systems where you needed to deploy a model with really high SLAs, and usually there was sort of like, a bunch of engineering teams involved as well as and when a new model would be rolled out, versus there were many other internal projects which still sort of like required a huge amount of compute to train and score that model, but the SLAs weren't really high enough. As well as, certain models that people were just training on their laptop, but they wanted to sort of like train those models reliably so that then they could write memos around how that model was performing, maybe sort of like, some offline analysis of an A/B test that was happening. And then also many of these ML projects, they ranged from sort of like a solo data scientist focused on it, versus say, like a team of 10, 15 data scientists working on a singular project. So our goal was, how could we sort of like ensure that all of these projects in their different stages of maturity, they all can sort of like, benefit from a cohesive ML platform. And the key sort of like, wait, what's happening? Sorry, my screen was frozen. Yep. And now, if you sort of like, look at the key concerns that our data scientists had, was they essentially had to battle two different kinds of complexity. So one was the complexity on the ML side of the house. How do you take a business problem and model it in mathematical terms and use sort of like, all the machinery that's available in the machine learning universe to get their work done? And then there was the entire engineering complexity that, okay, like how do I run my compute reliably when I have to scale out to the cloud to access more resources? How do I do that when I have to think about like A/B testing my models, or when I have to think about like, debugging anything that goes wrong? How am I sort of like, thinking about all of those engineering concerns? And by and large, our data scientists, they very much enjoyed tackling the ML complexity, because that's what they had sort of like, trained for. That's what they really sort of like wanted to do over and over again. But the engineering complexity was being sort of like a huge drain on their productivity. And for us, sort of like, the goal was that how can we sort of like make sure that our customers, our end users, they're not always sort of like fighting the engineering systems to get sort of like, even the simplest of model in production, and they can sort of like, focus their time on data science work, the work that's sort of like, a lot more valuable to an enterprise like Netflix and many others. So, so for us, rather than sort of like reinvent the wheels, if you look at sort of like, the basic components that organizations need for any sort of like ML activity, usually sort of like, it's some sort of like data layer. And these days you can sort of like get access to S3, GCS, you can buy like, Snowflake, Databricks, and many vendors offering many mature solutions on data platforms. When you look at sort of like compute platforms, there's Kubernetes, there are like a bunch of options by AWS, Google, Microsoft. You can sort of like, deploy Ray or Dask as well. And many of these tools are sort of like, again, very mature from an engineering point of view. Similar argument around like workflow orchestration as well. You have Argos, Airflows, step functions, and that layer is maturing as well pretty rapidly. Then when you look at sort of like the IDE side of the house, then, you know, most data scientists, if they are sort of like in the Python universe, then they want to sort of like use notebooks. If they are in the R landscape, then they're happy sort of like, you know, using RStudio or maybe sort of like, you know, PyCharm, and many other sort of like IDEs. So that's also sort of like, again, yet another mature stack. And then everything above that in terms of your training frameworks like TensorFlow, PyTorch, or if the organization wants to roll their own, again, there is sort of like, you know, some degree of maturity that we can expect. So in terms of the raw building blocks of the sort of like ML infrastructure ecosystem, very mature pieces have existed for a really long period of time. And we also did not want to sort of like reinvent those wheels. And our goal was that, okay, can we sort of like assemble this stack and provide sort of like an opinionated UX on top of the stack so that our data scientists can be productive. And we can essentially just piggyback on the great work that all of these communities are doing already for us. So let me sort of like, you know, just quickly go through what sort of like, you know, at a very high level Metaflow UX looks like, and then I'll quickly jump into a demo. So let's sort of like walk through a hypothetical project lifecycle. You know, a data scientist, let's say, they start. So you know, usually sort of like they'll start exploring within the confines of a Jupyter notebook. But then very often what happens is that, you know, while notebooks are great for exploration, they very quickly become messy. You know, there's like hidden state, people are still sort of like figuring out what's the right way of organizing notebooks, versioning them, sharing sort of like, you know, notebooks with one another. And for us, we sort of like, you know, position ourselves that either inside the notebook or outside the notebook, once sort of like you have done some early exploration, then it's the right time to sort of like start creating a workflow. And we want to lower the barriers of how easy is it or how difficult it should be to create this workflow. So for example, in the case of Metaflow, you can essentially lift your individual cell blocks into this workflow specification. So you can sort of like have this class flow spec, and you can have a bunch of Python functions that you can annotate with this decorator called step. And you can just embed your cells within this. And now this is sort of like a fully functional Metaflow workflow that you can then execute through sort of like, you know, Python myflow.py run. And now sort of like the interesting thing over here is around sort of like the state transfer, right? Like notebooks essentially sort of like within sort of like these different cells, you can access state from sort of like the previous cells that you have executed. And in this particular example, if you see, I have sort of like this variable self.x in the start step. And that variable self.x is available in the end step. So that's how sort of like you can deal with the state transfer. And when you sort of like execute a Metaflow flow through sort of like this Python myflow.py run, at that point, Metaflow will essentially snapshot and store all your execution. So it will assign a unique ID, an execution ID to that workflow. And then you can go back in time, and for any sort of like given ID of a workflow, you can access sort of like the code that executed that workflow. So you do not have to rely on sort of like, you know, explicit Git versioning. You get access to all the internal state that's been generated. And you can essentially sort of like, you know, within a notebook or any other Python process, inspect either your workflow or your colleague's workflow in a very straightforward manner. And that's all sort of like, you know, fine. You've sort of like now taken sort of like the contents of your notebook, and you are able to sort of like create a workflow in a very simple and straightforward manner. But now one sort of like issue that comes up very often is that, okay, you know, like even when you are using a notebook or, you know, running a workflow locally, you are still confined to the resources that are available to you within your workstation. And many times it may be the case that there is sort of like one step that needs GPUs, but you do not have GPUs attached to your instance. So how do you sort of like, you know, scale out? Maybe you need sort of like more RAM to process some data frame, and, you know, your laptop, let's say, maxes out at 16 gigs of RAM, but you need something like a 500 gigs of RAM. So in that particular scenario, you can sort of like very simply just slap in this decorator at resources, and you can specify what are the resources that you would need. And then what Metaflow will do is when you execute this workflow, it will essentially execute the start step in your cloud environment, and it will essentially sort of like make sure that your code is already available on that particular instance with the resources that you need. And then the rest of the workflow can then still continue executing on your workstation. So in this particular example, let's say, you're processing sort of like this pandas data frame, and that can execute on an instance with 128 gigs of RAM. And then the end step may very well just execute on your local workstation. And then Metaflow will take care of passing data around. So you do not have to think about sort of like how data transfer is happening behind the scenes for you. But then like one sort of like, common use case in machine learning is that at any given point in time, you don't want to train just one single model. You may want to train multiple different models. Say you want to train a model for every single country language combination. So if you think about Netflix, that's already sort of like, 1,000 models that you're training, or maybe you want to train models for like multiple different hyperparameters. So it's very likely that very soon you will be in a scenario where you want to sort of like run the same job over a different set of inputs. And we allow you to do that very trivially using sort of like, this notion of self.next, where you define sort of like your next stage transition. So you can also pass in a list. So in this particular scenario, I'm trying to sort of like train a model over this list of parameters, which has, let's say, 100 elements. And what that allows you to do is you can very trivially launch this workflow, and this workflow will run your first step on your workstation, and then it will essentially run 100 containers in your cloud, and each of those containers will train this model. And then the next step can still sort of like just run on your laptop, and you can collect all of the 100 models that you have trained and then decide what to do next. So you can very easily sort of like use many computers, and all this while your workflow is still getting launched from your workstation. Yep. So now, with Metaflow, you have now the capability of accessing compute in the cloud, and not just sort of like one instance or a handful of instances, but like hundreds and thousands of instances potentially, right? But then one of the biggest bottleneck that quickly comes about is that all of these steps that are running in the cloud, or even on your workstation, they need data, right? And even if you're able to sort of like launch these instances reliably and run sort of like this high scale workload, if you're not able to access data quickly, then it's very likely that you are paying sort of like, for a really expensive GPU instance, but that GPU isn't engaged, or you're just sort of like, waiting for data availability. And what we enable people is sort of like efficient data access from, say, for example, S3. So here's an example where, let's say, you have a data engineer who has sort of like, built a source table for you through some ETL process. And now you want to do some sort of like feature engineering. And one sort of like way to do that feature engineering step could be that, you sort of like launch a Spark job that creates sort of like this temporary table, my data. And this data may be sort of like backed by Parquet files. And then with Metaflow's S3 client, you can then essentially read these Parquet files directly from S3. And our implementation usually sort of like, gets you upwards of 10 Gbps of throughput. And in many scenarios, it's more efficient to read from S3 than sort of like, the local disk that's attached to your compute instance. And that sort of like just unlocks a variety of new paradigms of, how people sort of like think about doing these high performance computing applications. And then sort of like, now you have sort of like this workflow that's still sort of like running from your laptop, and you are able to sort of like access the cloud, and you're able to run sort of like, this really large scale compute. But then there comes a time when you would want to sort of like run this workflow at some schedule. You want to run this asynchronously, maybe sort of like, every single night, or maybe as soon as sort of like an upstream table partition appears, that's when you may want to sort of like kick off your execution. And again, rather than sort of like re-implement the entire stack, we piggyback on production grade workflow orchestrators. So one example of that is AWS step functions. Now, the good thing with these workflow orchestrators is that they execute a DAG. So we can essentially compile a Metaflow workflow into a step function state machine. And at that point, you essentially get the benefits of Metaflow. You get a great user experience of authoring these workflows, as well as all the benefits that Metaflow provides around like state transfer, versioning, all the ML specific concerns that it handles for you. And then you get all the benefits of a tool like step functions when it comes to high availability. Now I'm happy to announce that we also support Argo workflows, just like we do step functions. So there is a PR that I've been working on. So the PR is feature complete. And over the next couple of weeks, we are sort of like just going to finish up the documentation. And then hopefully early next month, mid next month, we'll be able to sort of like do a formal announcement of that. And I'll follow up with sort of like a demo of what that looks like after this presentation. But now, now you're at a spot where now you have a workflow that's now reliably running on one of these workflow orchestrators, let's say Argo workflows, right? Still, there are many things that can go wrong, right? Like, let's say you're depending on some version of TensorFlow, right? You still have to worry about like where are sort of like your library dependencies coming from. And let's say you decide to sort of like piggyback on some specific version of TensorFlow. Even if, let's say, you're always sort of like reinstalling that version of TensorFlow, it's very likely that, one of the transitive dependencies can break at any time. And now one of the issues with machine learning workflows is that compared to sort of like traditional software engineering workflows is traditional software engineering workflows will fail loudly. With ML workflows, your results are going to be just slightly off. And it's really difficult at that point of time to triage what really went wrong. Was it something that was wrong with the data? Was it something that was wrong with the implementation? Or did the universe just move around me, right? Like if, let's say, I'm installing TensorFlow, a specific version of TensorFlow, it may pull in a certain transitive dependency, and then that transitive dependency could change the next time I try to reinstall the exact same version of TensorFlow. And now you can essentially, one alternative to that is that you essentially bake your own Docker image, and then you ship that Docker image to all of your consumers. But then that again sort of like still begs the question that, okay, how are you still installing TensorFlow inside that Docker image and doing sort of like having reproducible Docker images or Docker files? It's still sort of like, really complicated. And we did not want sort of like our data scientists to sort of like concern themselves with that either. So for every single step, you can essentially also specify the dependencies that you need. And what Metaflow will do is it will essentially create a dependency log file for you behind the scenes, and it will snapshot all the dependencies and store that in S3. So even if, let's say, TensorFlow 2.5.0 and all of its transitive dependencies disappear from the upstream package repository, you will still be able to create sort of like this execution environment. That's something that Metaflow will guarantee for you. So you can sort of like lift and shift. So if it works on your laptop, you can essentially now sort of like get it working on Argo, step functions, Kubernetes, AWS, batch, wherever sort of like, you want to execute your compute. Now, we are now at a spot where, you have a workflow that's running sort of like reliably, and you have frozen the execution environment. User code is already frozen. And now you can sort of like only monitor for your data drifts, sort of like, something is broken. Now comes a scenario where, like now you have reliably deployed one workflow. Now your business stakeholders are happy. And now they want you to sort of like work on different variants of the same model, maybe sort of like experiment with different features. So what you may want to do is you may want to sort of like run isolated variations of the same workflow in parallel to sort of like try out different models. And now, how do you sort of like do that? Because now, if let's say somebody sort of like, just copies over your workflow and executes that workflow here over again, then there is a strong likelihood that it may just sort of like, just overwrite results somewhere where you did not intend it to. And with Metaflow, everything is sort of like very strongly namespaced. So you can essentially create a project, and you can create multiple branches of different projects and run them reliably with sort of like a strong guarantee that none of the results are going to be overwritten inadvertently. And what that means is that, let's say if you have a new data scientist on your team, they can very easily fork your project, and they can just like start executing it and start experimenting on top of it without sort of like, stepping over the production runs. Okay. Yep. But things will still fail. That's sort of like how things happen all the time. You deploy something on Argo workflows, everything is working fine. Data changes, something breaks. There are sort of like some failures that you want to sort of like handle gracefully. So you may want to sort of like retry a bunch of times, or maybe sort of like certain failures you sort of like just expect to happen, and you may want to sort of like catch those failures and move on to sort of like the next step. Metaflow sort of like provides you that capability. But then many times you may want to actually dig in, like what really went wrong. And let's say, you had sort of like a workflow that was executing on Argo workflows, and midway through that workflow failed. Now you may want to sort of like replicate that failure on your workstation, and then sort of like, just like change the code a little bit, and then again resume that workflow from where that workflow collapsed, so that you can sort of like get the confidence that, any sort of like changes that you're shipping, you're able to sort of like iterate on that quickly. And once you've sort of like figured out the right fix, then you can again sort of like deploy your workflow back to Argo workflow. So we need to sort of like complete that loop of like prototype to production and back to sort of like prototyping, debugging, which is what sort of like, Metaflow makes it super simple. So now it's demo time. So let me quickly get you to that. Let me share my terminal window. All right, so this is, let me walk you through sort of like, one of the workflows that I've written. So this is sort of like a very simple for each workflow. So in this workflow, I have a start step, and in the start step, let's say, I have this list of movie titles, and now I'm running the step A on every single element of this title, right? So I'm sort of like specifying for each titles. And in this, let's say, very simply what I'm doing is I'm assigning sort of like self.title that, I'm processing a given sort of like, let's say, Stranger Things title, and I'm just printing that here. And then I'm joining it. So in the join step, I collect all the titles that were individually processed. And then in the end step, let's say, I'm just sort of like printing the results, right? So what I can do very simply, and just like, one note here. So you can see sort of like, over here, people can sort of like access the inputs. And like, for example, in the join step, I assign self.results. And because this is sort of like, just wrote Python, in the end step, naturally, I expect sort of like access to self.results here as well. So what I can do is just do run. And this run step will essentially run my workflow, and it will assign this run ID, and it will run all of these steps. So for example, I expect 3 copies of step A to execute. So I see sort of like, 3 of those print statements, and then just 1 copy of the end step to execute. So I just sort of like see that over here. So you can see sort of like, there are like 3 different PIDs for the A step, and just like 1 single PID for the end step and the join step. So Metaflow is just running sort of like some sub processes on your instance. And you can also very simply sort of like, just tag any step with add Kubernetes or add batch, and we'll just sort of like lift and shift that particular step onto Kubernetes for you. And then you can also, let's say, yeah, so you can use the client to also inspect any run. So for example, I had this for each workflow, so I can check what is the latest run. And I'll say that the latest run is 8923. And then I can say that, okay, well, like for the latest run 8923, I'm looking at the step A. For the step A, the task that I executed, or let's say step end. And for the task that I executed, what is the data that I saw? So I can just do this, and I get access to sort of like, the data over here. And I can also sort of like just look at sort of like the step A tasks, and it gives me sort of like all the tasks that executed for this. And I can pick sort of like, the first task. I can pick any task, and then I can do it. Yeah, and then it sort of like, says Narcos process, and I can sort of like iterate through all the other tasks as well. Now I can also sort of like execute the entire workflow on top of Argo workflows. So I can just do, let's say I want to give it a different name. And then we will essentially just compile this workflow into Argo workflows. Can I share my entire? Okay, so I've shared my entire desktop. So you can just go to Argo workflows and you will essentially see sort of like, this for each flow executing, and it will execute all of these one after the other. And you get all the benefits of all the nice little utilities that Argo provides. So all the logs are available within that. So for example, now we have sort of like, 3 of these steps running. And like right before this, I actually ran one of the workflows. So for example, this is the for each workflow that I just executed. And you can essentially look at the logs for every single step that's available. So from an Argo point of view, it's sort of like a native Argo workflow. But then from a Metaflow point of view as well, it's a native Metaflow flow. So you essentially are able to get the benefits of both the universes. And you can also run sort of like, super complicated workflows as well. You can have like, dynamic nesting within workflows. So this is like one workflow that I ran. So we have sort of like the start step that leads to sort of like a for each. And then we run sort of like, an A step, and then there's a linear transition to a B step. And then we have sort of like a split step or a branching into a step D and an E. And then the step by itself sort of like, runs yet another map task. So we have sort of like, 3 different iterations of it, and then everything sort of like again joins it back. So that's pretty much sort of like where we are at with our Argo integration. And yep, that's pretty much it.
Awesome. Thank you, Savin. We do have a few questions in the chat. The first one's from Jesse. I don't know if you want to ask your question directly, Jesse.
Oh yeah, I was just actually wondering how it was possible for your S3 performance to be faster than say local disk. Like what techniques?
Yeah, no, I mean that's the beauty of sort of like advances in networking that AWS has shipped. I'm happy to sort of like, after this call, just like share sort of like some of the work that we have done on that regards. So there's already sort of like a component in Metaflow that you can use independent of sort of like the rest of Metaflow ecosystem, if you're curious to sort of like benchmark that. Yeah, but I mean, essentially what's really happening is if you look at sort of like the Bodo 3 S3 client, it doesn't sort of like maximize your network throughput. And so we essentially just run multiple instances of Bodo 3 to fetch sort of like to get sort of like, the most performance that we can get of your network card. And that network card is has a lot more throughput than sort of like any volume that you attach with your instance.
Cool. Okay.
Yeah.
And my second question was, so you showed 2 examples, one using the Kubernetes adapter or the integration, and then the Argo integration. Since Argo workflows is Kubernetes, what's the difference that they provide?
Yeah, great question. So Metaflow by itself is not a workflow orchestrator. So we do not deploy any service. So what you saw that I was executing through Metaflow was all a Python library. So when we are executing your Metaflow workflow locally on your laptop, at that point, it's just that Python library running a top sort and running one step after the other. And people may want to sort of like farm out compute or some steps of their workflow to Kubernetes. And but then there comes a point where now you want to just like run this workflow every single day. You do not want to sort of like, wake up in the middle of the night and schedule that execution from your laptop. So at that point, we would want to sort of like lift and shift that entire workflow and run it on top of, say, an Airflow, Argo, step functions at that point. So rather than keeping our own workflow.
Between the way the Metaflow with Kubernetes works versus Metaflow with the Argo, like
no, so we have tried to make sure that all the functionality that you get with Metaflow with Kubernetes is the exact same set of functionality that you get with Metaflow with Argo workflows on Kubernetes. The additional functionality that you get with Argo workflows on Kubernetes is that now there's a lot of work that has gone in and just like making sure that Argo workflows by itself is like fault tolerant, highly available. So we do not have to sort of like redo that engineering work. Those concerns do not exist when you're just running your workflow from your local laptop.
Got it. Okay, but the Kubernetes one is still able to use multiple pods.
Yes.
Okay.
Yes. Yeah. So you can essentially sort of like run your entire workflow on Kubernetes as well directly from your laptop. But then when it comes to scheduled executions or asynchronous executions, at that point, we would just want to offload it to some other service that can take care of that for us. So one integration that we want to execute on is integrating with Argo events. So that, let's say you have some data that appears in your data warehouse, that can trigger a bunch of events that a few machine learning workflows can be waiting on. Or, if you want to, let's say, string together multiple different machine learning workflows as well, then we can sort of like just have some event-based triggering for that, and achieving that on your local workstation wouldn't be feasible.
Cool, makes sense. Thanks.
I've got a challenging question for you. Who are your competitors? Not Netflix, but Metaflow.
Yeah, no, great question. I think when it comes to sort of like Metaflow, what we are building is an end-to-end platform. So people come to us having a variety of different needs. So there are folks, who are looking in the market for an experimentation management solution, and given Metaflow sort of like provides you that capability out of the box. So many sort of like tools in that universe see us as competitive. Then, of course, there are like similar workflow orchestration or ML focused workflow orchestration tools too. So that could be sort of like, yet another comparison that's usually made. I think historically what has happened is that we have been compared quite a bit with Argo workflows, step functions, Airflow. And with sort of like these integrations, we want to sort of like dispel that notion that rather than sort of like be competitive, we are like very complementary. We do not want to sort of like re-implement our own workflow orchestrator, as well as sort of like maintaining and deploying a workflow orchestrator isn't really that straightforward either. And many organizations, they may have other use cases for a workflow orchestrator beyond sort of like machine learning. So we are sort of like set on top of whatever sort of like our customers have made a choice of.
Okay, cool. Do we have any more questions? Okay, brilliant. Shall we give Savin a round of applause?
Well done. Thank you.
Okay, so that's the end of the presentations for today. Our next community meeting will be on the 20th of April. We are going to have a demo of Plumber from Eric Meadows. I'm actually not sure where he's from, which organization he's from, but I guess we'll find out next week. If you're interested in presenting at a community meeting, or you'd like to get involved in more community stuff, such as blog posts and the like, do let us know. You can drop us a Slack message. We're super keen for people to do more blog posts and so forth. So, and it's a lot easier than you think. So do let us know. If you have any more questions, of course, jump into the Slack channel and ask them. And the recording for this will be available before the end of this week. Okay. Thank you very much, and all have a lovely day.
Thank you. Bye-bye.
Thank you.
Thank you. Take care.
Thank you. Bye.